Now that we have our simple ERD and our full ERD, let's go ahead and start filling out the lab. The first thing I'm going to do is I'm going to copy and paste my image. And most graphics programs have a way of doing this. So Paint does, and Smooth Draw, which I'm using here, does. So I'm just going to go ahead and box select around the part of the image that I want and copy, Control C for copy. And then I'm going to go to the lab document, and under question 1, I'm just going to go ahead and paste right there. So that's all I need to do for the simple ERD. And then for the full ERD, I'm going to do the same thing. So let's go ahead and select the rectangle and then box select and copy and paste. So there's my full ERD as well. So question 3 asks you to state the relationships in English. And there's no need to be creative here. This is really straightforward. It's basically a SAC has one or many courses. Each course belongs to exactly one SAC. So the crow's foot notation here, one-to-many SAC has one-to-many courses. Each course has exactly one SAC. Each SAC belongs to one-to-many departments. Each department belongs to exactly one SAC. I'm sorry, a SAC has one-to-many departments. Each department belongs to one SAC. A department has zero-to-many assignments. Each assignment belongs to one department. Each assignment has exactly one instructor. Each instructor can have one-to-many assignments, and so on. So just go through the list, write these down in English. No need to be creative. One thing to do, though, after you've written these relationships down is double check them and make sure they make sense. So for example, if I had exactly one here, and I said each SAC has exactly one course, each course belongs to exactly one SAC, that wouldn't make sense because SACs have multiple courses. So try to use your common sense a little bit when you're looking at these relationships. For example, if you end up with something that says, for example, that each employee can sell exactly one item, or at most one item, well, there's probably something wrong in your ERD, or else you haven't stated the relationship correctly. So question 4 asks you to turn 4 of your entities into relations following the standard notation. And the only tricky part about this is understanding exactly how these relationships get represented in your tables. And the way it works is that there's going to be a primary key on the one side of the relationship. So instructor entity, each row will have a primary key value. And then there's going to be a foreign key on the many side. So for example, if I used first name, last name, middle initial, social security number, whatever, as the primary key, then I would have a foreign key here that referenced that primary key value. So that always goes on the one side of the relationship. The primary key always goes on the one side of the relationship. The foreign key that references it always goes on the many side of the relationship. Now, you're never going to have many on both sides here because we resolve those by creating intersection entities. So all of these relationships are either going to be 1 to n, like this, or 1 to 1, where exactly one of these has exactly one of these. In a 1 to n relationship, foreign key goes here, primary key is here. In a 1 to 1 relationship, it usually doesn't matter which side has the foreign key and which side has the primary key. You can generally just put the primary key on one side or the other and reference it from a foreign key on the other side. So let's go ahead and I'm going to represent instructor, assignment, department, and semester as relations. And I'm also going to toss in SAC, even though you're only asked to do 4 of them. So let's start with instructor. So instructor is on the one side of this relationship and the one side of this relationship, which means that its primary key is going to be referenced from these foreign keys. And then for the primary key, I can either use any unique combination of values. For example, I know that social security number is going to be unique, so I could use social security number as a primary key. I can't really use first name, last name because that's not going to be unique value for all instructors. Or I can create a surrogate key, which is an arbitrarily created ID that's automatically created each time I add a new record to this table. And to keep everything easy, I'm going to create a surrogate key and then use that as the primary key for instructor. So I'm going to call this instructor ID, and then this thing that references it, the foreign key, I'm going to call that FK underscore instructor ID. So FK to show that it's a foreign key, and instructor ID to show what value it's referencing. Now, in real life, you can basically name your foreign key anything you want to. You don't have to follow any particular convention. But this is the convention that the Fired Up database uses, and I think it's pretty handy. It's nice to be able to tell from looking at a column whether it's a primary key and has an ID in it, or whether it's a foreign key and is referencing some other ID. So I'm going to stick with that convention here. So let's go ahead and start with our instructor relation. And I'm going to start with instructor, and write the name of the relation in all caps. And then instructor has a primary key, which is a surrogate key, instructor ID. And then let's add a couple of columns. I'm less picky about your secondary attributes here. I'm mainly concerned with whether you get the foreign key on the right side or not. But I'm just going to toss in a couple of them to sort of illustrate what I'm looking for. So first name, last name, middle name, social security number. And then this one doesn't have any foreign keys because it's only on the one side of the relationships. So I'm just going to end it there. And then let's go ahead and do assignment. So assignment is on the many side of 3 relationships. It's going to need a foreign key for the instructor, a foreign key for the department, and a foreign key for the semester. So I'm going to name the primary key I already did, name this instructor ID, so this is FK instructor ID. And then this will be a department ID, so FK department ID, and then FK semester ID. So it's going to have 3 foreign keys. And for the primary key of the assignment table, I could just use a composite key with those 3 values in it. So I could have a composite key, FK instructor ID, FK department ID, FK semester ID. Those 3 values taken together will always be unique, and so I can use that as the primary key for assignment. Or I can create a separate surrogate key, once again just like I did for instructor, that's going to serve as the primary key for the assignment table. And I think that's a little neater here and a little more consistent with what I'm doing. So I'm going to go ahead and create a surrogate key here called assignment ID, and then it's going to have 3 foreign keys for the 3 relationships that it's on the many side of. So let's go ahead and do that. So assignment has assignment ID, oops, and FK instructor ID, FK department ID, and FK semester ID. And this particular one I don't actually need any secondary attributes on because it's just representing, it's just an intersection entity that's representing a ternary relationship. So let's go ahead and do department. Now department is on the one side of this relationship, So its primary key is going to be referenced by a foreign key here, and it's also on the many side of this relationship with SAC. So the primary key in the SAC table is going to be referenced by a foreign key in the department table. So this is going to have something like FK SAC ID. This will have SAC ID as a primary key, and then this will also have department ID as a primary key, and we already created FK department ID in this relation. So let's go ahead and do that one. So department has a department ID, which is a surrogate key, which I'm using as a primary key. And then it's going to have FK SAC ID, foreign key. And then I'm going to add some secondary attributes here. So I'm going to go ahead and let's say departments have names, and they have deans, and they have office locations. And I could add a lot more attributes here, but I'm just going to go ahead and stop there. And then let's go ahead and look at semester. So semester is on the one side of this relationship. So the primary key here is going to be referenced by a foreign key here. So we'll have semester ID here, which is a surrogate primary key, and then FK semester ID here as a foreign key. So semester has semester ID and doesn't have any foreign keys because it's just on the one side of the relationships right here. So let's go ahead and give it a year and a term. And then the last one I'm going to do is SAC. So SAC is on the one side of both of these relationships. So I'm going to use SAC ID as a surrogate primary key, and then department has FK SAC ID as a foreign key. SAC ID over here, and let's just go ahead and use name of the SAC. So now to finish this up, you're asked to underline all the primary keys and italicize all of the foreign keys. So I'm going to underline instructor ID and assignment ID, department ID, semester ID, and SAC ID. And then I'm going to italicize FK instructor ID and FK department ID and FK semester ID, FK SAC ID, and that's it. So question 5 asks you about your assumptions, and I talked about that a little bit when I was working through the ERD. So basically what you're going to look at is these cardinalities are a good place to start. So looking at these minimum cardinalities, if you had something that could have either been optional or required, and you had to assume that it was going to be one or the other, that's something you would want to write down under question 5. And on the maximum cardinality side, in a couple of places we have to decide whether the maximum number of things was one or many. So for example, teach assignment, we decided that this was many, so we had to create an intersection entity. But it might be possible that only one instructor can teach a section. So that would be another example of an assumption that you made when you were constructing your ERD that you would want to list there. Now another example is the way I'm dealing with assignments. So right now, I have an instructor who's assigned to a department for a semester, and then the teaching assignment is actually separate. So the fact that the instructor is teaching a particular section, that's separate from the fact that the instructor is assigned to a department for the semester. But maybe these two things are really the same thing. Maybe you're assigned to teach for a department, and you don't actually need this assignment record here at all. So that's an assumption I made as well. Can you be an instructor who's assigned to a department for a semester without actually having any sections to teach? Or can you get a teaching assignment when you haven't actually been assigned to a particular department for the semester? If the answer to those questions is yes, then you would want to have two separate entities. If the answer is no, then you really don't need two separate entities. You just need this assignment record, and you can get rid of this teach assignment. So that's another assumption that you might want to look at. So question 6 asks about weak entities. And a weak entity is something that can't exist unless it's tied to another entity. So for example, this enrollment record shows that a student is enrolled in a section. It can't exist unless there's a student to be enrolled, and it can't exist unless there's a section for the student to enroll in. So that makes enrollment a weak entity. You have to have both of these things before this thing can exist. On the other hand, semester is not a weak entity because you can have a semester even though there are no instructors assigned for that semester and even though there are no sections being offered for that semester. So semester is not a weak entity, but enrollment is. Assignment is another weak entity because you can't have an assignment without an instructor who's assigned to teach the course, a department that they're assigned to teach for, and a semester that they're assigned to teach in. So assignment is also a weak entity. Generally speaking, most of these intersection entities you create are going to be weak entities. And most of the entities you started out with are probably just going to be strong entities. So go ahead and find a couple of weak entities in the ERD for the Fired Up database. So question 7 asks about identifying two intersection entities, that is, entities that were used to break apart an end-to-end relationship. And we saw how that worked here. So I created enrollment. First I created section to break apart a ternary relationship between instructor, course, classroom, date, time, and student. And then I had an end-to-end relationship between section and student. So I resolved that by creating an enrollment intersection entity. So find similar examples from the Fired Up database. So for question 8, here's some data, and you're asked to explain why buyer determines department, but department does not determine buyer. So determine in this sense basically means that if I tell you the name of a buyer, you can always tell me the name of a department. That's what determines means. For any distinct value here, you're going to have a corresponding distinct value here, exactly one unique value. So the question is, if I tell you a specific department from the list above, can you always give me exactly one value for buyer or not? If you could, that would mean that department determines buyer, and if you can't, that means that you can't determine buyer from department. So go ahead and explain why buyer determines department, but department does not determine buyer. And then finally in question 9, we're given some types for the columns in the SKU data table. So there's a SKU column, and this is a 6-digit number, a SKU description, which is going to be a piece of text up to 128 characters long, and a buyer, which is a piece of text up to 64 characters long. And then here's how big each of those field values is in terms of disk space. So you can represent a value for a numeric 6,0 column for one row takes 5 bytes. And how much space total would the SKU Data 4 table take, given these data types, if you had 500,000 products? So it should be a pretty simple calculation. in real life, there's some overhead associated with your table as well. You can have indexes and you can have metadata. So the number that you end up with is actually going to be a little low in terms of what will actually be used, but don't worry about that. Just figure out the storage requirements for the table data part. So good luck on Lab 5, and let me know if you have any questions.